Okay, the last question for the review test. I'm going to take some time to understand the setup of this experiment. The first thing you got to realize is that all of these electrodes here are reactive electrodes because they are the metal that are also in the solution. So L and M, they are copper electrodes and they are in a solution of copper nitrate, so they are reactive. Electrode N and O, they are silver electrode and they are in a solution of silver sulfate, so they are also reactive. The first thing that I can write down would be the polarity of electrode O, because I know that this battery is a negative N, and I know that therefore O is also a negative N. This is the positive end of the battery, so L is also the positive end. Okay, electrons will flow out from the negative end of the battery into electrode O. Okay, and the silver plus from the silver sulfate solution is going to get picked up. They're going to pick up electrons flowing into the electrode and become silver. So therefore, you would expect electrode O to have an increase in mass. Since this is electrolysis, you will know that because O at electrode O we have a reduction occurring, so at N it will be an oxidation occurring. So silver will be oxidized to become silver plus, and the electrons produced will be flowing from electrode N to M over here. Electrode flowing into M, they are going to get picked up by the CO2 plus solution, CO2 plus inside the solution to become copper. So again, you will expect a mass increase of electrode M. Now, since this is a reactive electrode, Cu of the copper in electrode L is going to get oxidized to become Cu2 plus, giving 2 electrons, which will go back up to the battery and get pumped all the way to electrode O again. Yeah, so thereby completing the circuit. Well, for B part 1 and part 2, the common mistake is that the Cu2 plus over here and Ag plus, you got the wrong charge on the metal, on the ion. So you got to be sure that Cu has a charge of 2 plus and Ag has a charge of plus. For C, I've gone through it previously in my briefing just now, so I'm not going to go through it. Okay, so let's go on. Okay, for D part 1, we know that in the previous briefing, electrode M and electrode O, they are both going to be having an increase in mass, because electrode M, you have the copper 2 plus getting reduced to become copper, and for electrode O, you have the Ag plus getting reduced to become silver. And the thing is, silver needs only 1 electron to get reduced to become silver metal, while copper needs 2 electrons to get reduced to become copper metal. So by the fact that silver requires less electron for reduction, this is one reason why electrode O will increase in mass at a faster rate. But more importantly, we got to compare the molar mass of silver with the molar mass of copper. Silver has a molar mass of 108 grams per mole, while copper has a molar mass of 63.5 grams per mole. So to get the full marks for this question, you got to tell me that because of the difference in molar mass, so silver electrode O will have a mass increase at a faster rate. And it's not just enough for you to tell me that because the electron requirement is different. Therefore, the electrode O will have a faster increase. Okay, for question part E, if electrode L and M were replaced with platinum electrode, gas bubbles could be observed at one of the electrode, and you were asked to suggest where the gas bubbles can appear. So let us take a look at the diagram. Okay, so you can see that at electrode L over here, electrode L, we are experiencing an oxidation, and at electrode M we are experiencing a reduction. So if we were to replace both electrode with now they are copper, so if we were to replace them with platinum, we would expect oxidation to take place at L and reduction to take place at M. So if L and M both are platinum electrode, we will have to consider the oxidation of either OH minus or NO3 minus at the platinum electrode L, in which case we will choose OH minus to be oxidized to become O2 and H2O, because in terms of the selectivity of discharge, OH minus is preferentially discharged to NO3 minus. Yep, so we should be able to see bubbles of oxygen at L. For electrode M, which is now a platinum electrode, we will have to choose between H plus and CO2 plus. And it is quite an easy choice. From the preferential discharge table, we will know that CO2 plus is going to get discharged to Cu more so than H plus to become H2. So we will not see any bubbles of hydrogen gas at platinum electrode M, but we will see a coating of copper on platinum electrode M. Yeah, so there you have it. The electrode where the gas bubble will appear is electrode L. Okay, and we write a simple equation to represent the oxidation of OH minus to give oxygen gas and water. And that is the end of your RT solution. If you have any questions, you may approach your chemistry tutor, most of which is me, and for 1-1 is Miss Vivian Ng.